Hey, welcome Mechanical Tools 1 learners. Today I'm going to do a little discussion, and discussion is going to be focusing on precision measurement tools or instruments, and in this case we're looking at calipers. Okay, so you can see here I've got three types of calipers. This one in the back is a special one, and I'm excited to show you how that one works. But as you can see, we have two versions. We have what's called a dial uh, caliper, and you can see it has a dial right there. And then the next one is a digital one. That one allows the reading to be read directly from the LCD display. So the way the caliper works is it has parts like everything else. Okay, so let's look at the parts of the caliper. And as you can see, here's the dial right here, and it has a series of numbers, and those numbers equate to how we're going to measure the object that we want to know what the dimension or dimensions are. And we have two sets of jaws. This is the outside jaw, and this is the inner jaw. And the outside jaw allows us to measure the diameter of that particular object. So if I open up the jaw, I would actually put the part inside the jaw here, and then I can take a reading off of the caliper, meaning the dial indicator. We have, and this is for outside diameters if you're measuring like tubing or some type of circular part. The top jaw is for inner diameter, so you can measure the inner diameter of, say, a pipe or some type of tubing. We have down at the bottom, we have the adjust screw, meaning the zero calibration screw. So occasionally we need to recalibrate or set this gauge back to zero, and we can do that by adjusting this screw, and then we rotate this ring, and that will allow us to make that adjustment. Also, we have the locking screw. So this part right here is the carriage. I've got to get in here. Right here, that's the carriage. And we can move that carriage by using this little wheel, and this is like our thumb rest. And once we get that position in place, we can actually come up here and lock that dimension in so it won't move, and then we can record it as need be. Okay, so also on the dial caliper, or the calipers in general, we have this little guy back here, and this is for measuring the depth. So it's like a depth gauge. So if I want to measure the hole of how deep a hole is in a cylindrical object, I can do that with that guy right there. Okay, so that's the caliper, dial caliper. The digital one is, again, no different. It has the same parts, except it has what, a digital display, so you can see that, and we can actually toggle between inches to millimeters. If you want to zero it out, we'll just push this button right here, and then it's zeroed out. Now, traditionally, we don't zero it out right here. We want to zero out where the actual jaws are closed, right? So if I zero there, then I'm all set, and I can take that measurement. And again, it has a locking screw to lock in the carriage, and of course, it has a push button to calibrate the caliber right there. And then you can see right here, it has the same effect of sliding the carriage, and we can get our reading based on what we're measuring between either the outside jaw or the inner jaw. Okay. Now, the piece of resistance, as I call it, is me being an electrical engineer, always looking for challenges and saying, hey, how can I effectively turn devices and make them smart? So that's what I have right here. This is, let's move this guy out of the way. This is a what I call a little smart dial caliper. And the way it works is you can see right here, I'm going to bring this vise in here. I have the object that I want to measure, meaning in case this boat. And the way it works is, if I was in a production setting and I was bringing in folks that aren't familiar with using precision tools, well, this is a little test fixture. So what it allows that person to do is, if we're making boats and we want to make sure that that shaft, or in this case the shank, is good, the diameter, again, bringing in someone from outside, they don't need to really know how to take the measurement, that is, to read the measurement. They just want to make sure that this part is within spec. So the way it works is, basically, let me see if this is going to run here. I'll open up the jaw, and then I'll place this guy right inside the jaw, and hopefully you can see that. Let's see, right there. And there's a little LED indicator light that turned on, and then I can actually take the reading. Okay, and I have a little monitor over here, and let me see if I can rotate that around. Got to get him popped up here, and it's actually, let me see if I can get that position. It's actually reading what that value is, which is 0.392 inches. Okay, so I have a way of, again, bringing someone outside, meaning off the street, right? And I'm trying to maintain production, and I'm trying to meet the delivery date of my part to my customer. So now I have this fixture where I can actually test to make sure that, in this case, the bolt is within spec, and that person coming in, all they got to do is just take the reading, as you can see here, and they can see that it's good. And of course, the over here on the monitor, it'll actually read what that value is. Okay, so, and it's real simple. I just basically took, as you can see, 2 binder clips. I have what I call sense wires, and those sense wires, when they touch each other, they complete a circuit, and then the little brains here, which is a Raspberry Pi 4, it's the latest one. This is like an 8 gig little mini computer. I wrote some software in Python, and now it can actually read what that value is based on the position that you see here. This is my little adjuster, and it'll actually read the value, and it'll basically turn on that LED, and there you have it. So a means of, providing a little bit of automation, and also sometimes you will have to be able to make fixtures that will allow folks to use the instrument, get the data, and then go from that point in terms of doing further analysis. Okay, so that's something I always like to do. It's a very powerful skill set to have, and for you folks who are taking courses that you may ask the question, why do I need to know electric circuits? Well, here you have it right here, a good example of why you need that. But this week, just to kind of wrap things up, this week you guys are going to get a chance to dive deeper into calipers, in this case dial calipers, and I found a real nice simulator, and I'm going to create a little worksheet from that simulator so you can practice reading the the actual dial indicator, right? And also doing some conversions, meaning inches to millimeters. Okay, so that's what's on tap for this week, and you guys have an awesome week, and we'll talk to you later. Bye.